All right, happy Tuesday, everyone. Welcome back. 414. What is the rule and how can I use it? And this is what I have been waiting for such a long time. You have no idea how long I've been waiting for. But today we are formally introducing what's called y equals mx plus b. Okay? In lesson 412 and 413, you investigated connections between tile patterns, x, y tables, graphs, and rules or equations. Today you will, and by the way, just whenever you see rules basically mean what the equations are. What rules guide the equations and they work together. Today you will use your observations about growth and figure 0 to write rules for linear patterns and to create new tile patterns for given rules. Okay? And that's the key thing right there, growth and figure 0. Okay? All right, let's tackle it. Problem 430. So on your paper, please write down problem 4. Again, 414, right? Nice and big, 414 on your paper. This is problem 430. With your team, list some of the equations you have been working with in the past 2 lessons. What do all of these rules have in common? So think about what we just did today in class, what we talked about last Friday. All of these rules, the rules were like y equals 4x plus 2. Remember that? Then we had another one that was y equals 4x plus 1 and y equals 4x plus 3. And then we also had the y equals 2x plus 3, right? And if you notice, what do they all have in common? Write these down. They all have the same format. They all have the y's at the beginning, y equals, and then something times x, and then plus something at the end there. So they all kind of have that same format, okay? Good. Now, understanding y equals mx plus b. Rules for linear patterns can all be written in the form y equals mx plus b. Please write that down. Y, problem 431, right? Y equals mx plus b. Rule for linear patterns. In other words, whenever you see an equation written that way, it's always going to give you a linear pattern. In y equals mx plus b, x and y represent variables, quantities that can change. Like these right here, I could plug in anything. Remember when we were talking about figure number? I could plug in anything here for figure number, and then I'll solve it, and I'll get the number of tiles there. So you can plug in anything for variables, okay? However, m and b represent parameters. Parameters are numbers that stay the same in the equation after they are chosen, okay? So for example, right here, look at these problems right here. This 4 never changed in our equation. You will never, oh, well, we're going to follow this rule for the first couple figures, and then after that, this is going to change to a 7, and this change to a 5. No, these numbers do not change. Once you pick them for that rule, that's always the way it's going to be for that pattern, okay? They're called parameters. Variables, again, the letters x and y can change. You can put in a different figure number here, like figure 100, and then you'll get the different number of tiles there. So x and y can change, the parameters can't, okay? However, here's the key thing. What does m tell you about the pattern? M is this first number. Do you remember what this number told us about every pattern? Do you remember? Do you? Please write this down. M equals, it is the growth. It is the growth. It is how much you're adding every time. How much is it growing by every time? That is your M. M is referring to growth. And what does B tell you about the pattern? When we talked about it today and yesterday, what does this last number tell you? You know it. It is B. And now it's the number of tiles in figure 0. The number of tiles in figure 0, okay? So if I work my way back and found figure 0, that always tells me that information. And that's it, everyone. M is your growth. M is how much you're growing by every time right here. And this last number, the B, or the letter B, tells you how many tiles are in figure 0, how much we're adding, okay? So let's try one here. Graph to rule. Alicia claims, this is problem 432, claims that she can find the equation aligned with its graph without using a table. How is that possible? Discuss this idea with your team and try to find the equation of the line it right without making a table. Be ready to share your class. So you're not going to share all that, but just look at that table, please, or look at that graph. Just by looking at the graph, I can write the rule pretty quickly. Okay, now of course I'm the teacher, but you could probably do it pretty quickly too. In fact, some of you, you already have the rule. Some of you are not quite sure what's going on, and that's okay. Look at what they did here. They did draw this little triangle here, which is interesting. What does that do? Oh, okay, so figure, look at this is figure 0 here, figure 1, and they drew this triangle. What does that figure show us? So figure 0 has 1 tile. Figure 1 has 4 tiles. So what do you think? Well, if I look back, remember y equals mx plus b, where m is your what? It's the growth. How much is my tile growing by? How many tiles am I adding every figure? If 1 has 4 and 2 has 7, and 3 would have 10, I'm always growing. Look at that. 1, I went over 1 figure number and I went up 3. And over 1 and up 3. So this tells me my growth. So y equals 3x plus, but remember, this is the number of tiles in figure 0. How many tiles in figure 0? 1 plus 1. That's it. Isn't that cool? That's my rule. So I just find how much is it growing by. It went from 1 to 4, so it grows by 3. That's my growth. And then this right here tells me my figure number. It tells me how many tiles are in figure number 0. So 3x plus 1. Okay? All right, that is it for today. That's it for your video tonight. So hope that made sense. Tomorrow we're going to pick up where we left off on. This is a really exciting time because these are some really cool things that are going to make things a whole lot easier for you. So hopefully it helps a lot. If you got questions, check with me tomorrow. Okay? Have a good day.